Hello 4A. So since the session was a little bit laggy, I told you that I'm going to do the second session as a recorded session where we're going to finish what we were supposed to finish in the session. So let's start together. We were answering the worksheets. First, there was a part where, from the homework that we were correcting, and we stopped at page 23, question number 15, and I told you that I'm going to repeat this question for you since it wasn't that clear when I was in the session because of the lagging and the internet connection. So let's do this together. In this page, in page 23, number 15, the question says, 4 children are fighting over the same toy. Mike is pulling north with a 50 Newton force. Justin is pulling east with a 40 Newton force. Chantal is pulling south with a 50 Newton force. And Takira is pulling west with a 30 Newton force. I told you that while you are reading the question, translate the information that you are given into a simpler notes on the diagram. So here is the toy. This is the toy that the children are fighting over. And we're going to translate every single statement with a simple arrow and a label next to it, okay? So here's the toy. It says Mike is pulling north with a 50 Newton force. So north is up, okay? So I'm going to draw an arrow up and I'm going to write 50 Newton next to it. And now I know that Mike is the one who is pulling north. So I'm going to write Mike. Okay, the next statement is that Justin is pulling east with a 40 Newton force. East is to the right. So I'm going to draw an arrow pulling to the right, and I'm going to write that it is being pulled with a force of 40 Newtons, and that the one who is pulling to the east is Justin. I can just put the letter J, okay? Next is Chantal is pulling south with a 50 Newton force. Where is south? South is downwards. So I'm going to put an arrow downwards, and I'm going to write that it is being pulled also with 50 Newtons, but by Chantal. So I'm going to just write CH next to the arrow, stands for Chantal, okay? And the last one is that Takira is pulling west with a 30 Newton force. So this is the only arrow left. I'm going to write the amount of force being pulled to the west, 30 Newtons, and that Takira, I'm going to just write the letter T, is the one who is pulling this way, okay? Now, the first question says, draw and label the forces on the diagram. So we already did this, and I told you yesterday that when you translate the question, it will make it very much easier for you to answer all of the questions that will be given for you over this paragraph. Okay, so the first question is already done. Draw and label the forces on the diagram. Okay, so I already did this. The second question says, in which direction will the toy move? All right. So we noticed that both Mike and Chantal are pulling with the same force and in opposite directions. So this is the two conditions that we are looking for in any to call a force a balanced force. If I want to know whether this force is balanced or not, I have to look for two things. The first thing is the force, the amount of force, it must be the same. And the second thing you're looking for is the direction of the force. The direction of the forces should be opposite to each other. In this case, I will say that this is a balanced force. A balanced force means that both forces are canceling each other. So it's like they do not exist at all. It's like both Mike and Chantal, the total of their forces is 0. They are not affecting the movement of the toy because they are not moving it, since both of their forces are equal and they are opposite in direction. So they cancel each other. So this leaves us with the force that Justin is pulling with and the force that Kira is pulling with. So in this case, we have to look at the greater force. In this case, Justin's force is the greater force because he pulls with 40 newtons while Kira only pulls with 30 newtons. So this means that the direction that the toy will move to is the direction that Justin is pulling to, which is the east direction. So I'm going to write the answer right here. It is east. Okay, so this means who gets the toy? The one who gets the toy is Justin. Right? So this is the answer for this question. Now I'm going to wipe this answers and I'm going to go to the next page. In the next page, now in the next page, we have also 2 word questions that you will that you're supposed to be translating, as I told you in the previous page. So you again read the question and then you start translating the question. I think we already did this together. So I'm going to skip that. Yeah, I just checked. And yes, we already did this together. So I'm going to skip to page 26, which is the last. Yes, we did page 24 and 25. So I'm going to skip to page 26. In page 26, that was the 3rd page of your homework and the last page of your homework that was dated April 27th. So let's start answering together. Worksheet number 19, it says choose the correct answer. The first question says when an object falls, a resistance, let's read the choices, acts in the opposite direction to the movement, acts in the same direction as the weight, does not act at all. So we know that the A resistance, as I told you several times before, is a type of friction. So since it's a type of friction, and we know that friction always opposes the direction of the movement. Opposes means that it works in the opposite direction of the movement. So this means that the answer will be the first choice. Okay, so I'm just going to tick the first choice. This is the answer. It acts in the opposite direction to the movement. Next is weight is a force and is measured in. We know that all forces is measured in newtons. Number 3, where would you feel heaviest? The earth, the moon, you would feel equally heavy on both. Okay? So the idea is with the gravity. You will feel the heaviest on earth. And how did I know? Because we answered a question already in page, let me check, I think it was page 27, if I'm not 27. Yes, this one, where we said that Earth's gravity is 10, while the moon's gravity is 1.7. So this means that on Earth, the Earth is pulling you stronger to it than the moon is pulling you towards the ground of the moon. So this means that you will feel heaviest where you will feel heaviest on Earth. Okay, so the answer is on Earth. All right. So I'm just going to erase this and I'm going to continue answering the rest of the page. The rest of the page, yes, number 4 says, which of the following is true? Gravity only acts through air, not through water or land. gravity does not act on aeroplanes flying in the sky. Gravity always acts towards the center of the earth. The answer is the third choice. Gravity always acts towards the center of the earth. Gravity works in general. It does not stop working in any point, whether it's a flying airplane, whether you are in the air, whether you are in the water, whether you are walking on land. Gravity works everywhere. Maybe in water, there is some other forces that acts in the opposite direction of gravity, but that doesn't mean that gravity does not exist at this point. Gravity will always be there, but some forces are just acting in the opposite direction. Number 5 says, which of these is not a force? Let's read it. Friction, weight, and height. So we know that friction is a force. We know that weight is a force. So this leaves us with height. Height, of course, is not a force. Number 6, which of these is false? The first says, a moving object carries on moving until a force stops it. Okay, so this is a true statement, so it is not false. The next choice says a moving object eventually runs out of force and slows down. This is what is wrong. This statement is wrong, and let's read the third choice and then I will explain why. A moving object travels in a line until a force changes its direction. Okay, so this of course is a true statement, so this is not the answer. The answer will be the second choice. Why? Because the objects do not run out of force. The force will be or will keep affecting a moving object until another force comes and stops it or slows it down or change its direction. So it never ends. The force never ends until another force come and act in the opposite direction. Okay, so that was the correction of the homework, and this will leave us with 2 pages of classwork that we were supposed to do yesterday, which is page 28 and 29. So let's do them quickly together. In this worksheet, this is page 28. It says, which of these surfaces is likely to be the most slippery? So you are looking for the surface with the least friction. So which one of those is most slippery, which means that you can slip easily or you have the least friction in it? Is it the smooth, dry surface, or is it the smooth, wet surface? Is it the rough, dry surface, or is it the rough, wet surface? So I will leave you with like 30 seconds to think about this answer. So the answer will be, if you chose smooth, wet surface, you are correct, because the smooth, wet surface has the least friction, so you can slip easily on it. Number 2, a cyclist is riding along a level road. She stops pedaling and the bicycle slows down. Take these statements true or false. There is a force keeping the bicycle moving. Of course, if the cyclist is cycling, it's supposed to be keeping it moving, but she stops pedaling. They said that she stops pedaling, so there is no force that is keeping the bicycle moving. When she stops pedaling this way, you are not applying any force on the bicycle to keep moving. So the answer is false. There is no force that is keeping the bicycle moving since she stopped pedaling. The next statement says there is a force slowing down the bicycle. So of course, because she stopped pedaling, apparently the bicycle should be keeping the force, and this force will keep the bicycle moving until something tries to slow it down. This thing could be that this girl pressed on the brakes. So this could be the reason why the bicycle slowed down. Or the other thing is that the cyclist is cycling on a rough surface. So in this case, the force, this surface, the friction will slow it down. So since the bicycle started to slow down, this means that there is a force that is acting on the bicycle to slow it down. So this means that it's true. Okay, so I'm going to just wipe this and let's go to the next question, which is question number 3. Okay, in question number 3, they say some children investigate how easy it is to make a trolley start to move along the floor. They tried different floor coverings. Okay, so they have a trolley. A trolley is like a small train. So they are like playing with a toy, which is the trolley, and they want to know how easy it's going to start moving on a floor with different coverings. So they have the trolley and they have the floor, and they start to cover the floor with different coverings. What are the coverings that they are using? It could be a wooden floor, or maybe they added on the wooden floor a thin carpet. And then after that, maybe they tried a thick carpet, and then they tried plastic tiles. Okay. Now, and then they connected the trolley to a force meter to see when or how easily or how much force should be applied on the trolley in order to start moving on each of those floors. So again, they connected a force meter to the trolley, and then they started to cover the floors that they want the trolley to be moving on with different coverings. They tried first the wooden floor, and when they tried to move the trolley on the wooden floor, the trolley moved when we applied a force of 6 Newton, on the trolley. It was able to move when I pushed the trolley with a force of 6 Newtons. When I put a thin carpet, the trolley moved when I pushed it with a force of 12 Newton. So I have to exert more force or more effort to make the trolley move on a thin carpet. When I use the thick carpet, I have to apply a force of 14 Newton. So this means that I applied even more force to make it move on a thick carpet. And the last one is that I applied about 8 Newtons to make it move on a plastic tile. Okay, so now let's read the question. Write the correct units for measuring force by the side of the bar chart. So this is, I already answered it. The force meter reading, the unit of the force, of course, is Newton. So I'm just going to write it right here. It's Newton. Okay. If you want to write it as a whole word, and that would be better, just write Newton. Okay. All right. The next, on which surface was it easiest to move the trolley? So you are looking for the floor covering that I exerted the least amount of force to make the trolley move on it. So this means that, let's look, I exerted 6 Newtons only to make it move on a wooden floor. I exerted 12 Newtons to make it move on a thin carpet. I exerted 14 Newtons to make it move on a thick carpet, and I exerted 8 Newtons to make it move on a plastic tile. So this means that the wooden floor is the floor or the surface that I did not make that much effort to make the trolley move on it. So the answer is wooden floor. Next, which force affects how easy it is to make the trolley move? Which force affects how easy it is to make the trolley move? So what is the force that is acting opposite to the movement? We know that we are moving something and there is a force that is acting always on the opposite direction. And this is the force that determines or tells us whether the movement of the object will be easy or hard. So think about it a little bit. If you got the answer as friction, then it is correct. The friction is the force that shows us whether we can or that determines or tells us whether the object will move easily or slowly, easily or hardly. The last question, the children try pulling harder. What happens to the trolley's movement? The children try pulling harder. What happens to the trolley's movement? So this means that when you try pulling harder, the trolley's movement will be, if you think about it, I will leave you to think about it for 30 seconds. All right, so when you pull harder, this will affect the speed of the trolley. So when you pull harder, the trolley will move faster. Okay. All right, guys. So I'm going to erase and let's go to the last page of our classwork, which is page 29. In page 29, we have here the children investigate parachutes. So they did what? They bring a piece of cloth and they connected it with several strings, and at the end of the string they put a stone or a rock. The question says, which force makes the parachute fall toward the ground? So what is the name of the force that is pulling everything? Okay, let's continue. Sorry, guys, a problem has occurred. So again, the children investigates parachutes, as you can see. Which force makes the parachute fall towards the ground? We know that the force that is pulling everything to the ground is the gravity force. So this is an easy one. Next, which force slows the parachute down as it falls? So we know that when the parachute is falling down, there is a force that is trying to push it up. And this force is the air resistance force. Okay.